Very good afternoon, students. Can we quickly do a readability check? I'm trying to be a little quiet than usual, so please tell me if you can hear me on a scale of 1 to 5.
Good afternoon, sir. Radio 5, Victor Tango, Oscar Delta Alpha.
So Radio 5 Victor
Harsh,
Tango.
Nukul, Karishma, Prakhar. How do
Radio
you
5,
read?
sir. Victor Tango Papa Romeo Sierra.
I think I have a problem with my receiver. Please carry on with the readability check.
Radio 5 sir Victor Tango
Radio
Kilo.
5, Victor.
Okay, can we try again?
Radio 5, Victor Tango November Kilo Charlie.
So I have to work on the volume. Stand by. Okay, so I want everyone to at least send me an exam date and how many lectures you have covered thoroughly. I think you'll have had access till L22, right? So quickly, as a reminder, so our action plan is going to go ahead according to this, okay? Because we have to be quick. And at the same time, we have to be informative. So the exam is easy. What makes it more easy is that we're taking the time out to master all concepts. You can easily do question bank and go and expect, even after doing basic. But to choose to study, I'm very happy. Okay. So we're going to do it in a way that we can actually picturize the environment with respect to all these conditions. So what I would suggest, what we can do collectively, every time we're starting a topic, you try to get me real life pictures in the session and keep sharing whatever you can find, just like we did for a few lectures in TechGen. Okay, so we'll share it with everyone. We'll compare it with the real deal, and every student can use their individual expertise with respect to their real life knowledge. Like I'm sure Harsh has a lot of real life knowledge to share with respect to how metrology is dealing, how metrology is dealing with daily civil aviation operations. Like you don't just have a job to just get into the cockpit and fly. Although you'll be briefed about the weather, it's good to understand the weather. Sometimes unpredictable things can happen. Correct? Students, I cannot see all. Can I see everyone? Harsh, I remember you had a suggestion with respect to topics. So I want you to discuss the same. The highlighted ones are the one are you talking about, or the ones that are not highlighted? Please talk to me. And if I don't think I can hear you all, so please do a readability check. I need to check the volume.
Radio 5, Victor Tango Oscar Delta Alpha.
हाँ हर्ष तो क्या बता रहे हैं आप हाईलाइटेड वंस या नॉन हाईलाइटेड वंस क्या क्वेश्चन था आपको
सर जो पिंक कलर में हाईलाइटेड थे ना, मेरे को बस ये कंफ्यूजन था कि ये टॉपिक्स हमने किए नहीं है। लाइक वो 22 लेक्चर की सीरीज में थे, तो ये इम्पोर्टेंट है करने के लिए या नहीं करना है हमको?
एक बार मैं चेक कर रहा हूँ नुकुल व्हाट्स हैपनिंग एग्जाम डेट्स बताइए
Sir, I'm not yet.
Students, I'm having a difficult time hearing you all. Just give me a second now. Nukul, keep saying na something.
Yes, sir.
I think this is better. Prakhar, can you do a quick readability check? लंबा कुछ non-stop. And Nukul, प्रखर के बाद ब्रेक बोल के आप करो फटाफट
Mumbai ground, Victor Tango Papa Romeo Sierra. On 121.5. Readability, pre-flight readability check. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. How do you read?
Victor Tango Papa Romeo Sierra, Mumbai ground, read you 5. How do you read?
Read you 5. Strength 5. Victor Tango Papa Romeo Sierra.
Actually, I was able to read you 4. It was not that loud. but compared to what I had earlier, this is great. Um, Prakhar, can I see you? Krishma, आपके अपडेट्स में चेक कर रहा हूँ. तो शायद कहाँ पे है? Harsh looking good, Nakul looking good, Prakhar looking good. Yesterday I met someone from Lucknow, so I was thinking about Prakhar. I remember you wrote something about the place. That was amazing to read because I think that was my first introduction to that city. Nakul, what's happening? अपडेट्स दे दी हैं सारी मेरे को, मैं चेक कर रहा हूँ. मुझे सिर्फ प्रखर एंड करिश्मा की
Yes,
अपडेट्स आई हैं. हर्ष, आपकी नहीं आई हैं. एंड नकुल, एग्जाम डेट्स
सर
एंड
एग्जाम
लेक्चर.
अभी सर मैंने फॉर्म अभी तक भरा नहीं है, बट मैंने टॉपिक्स जो है सारे ऑलमोस्ट कवर कर लिए. बस फॉर्म एंड विजिबिलिटी एंड आई हैव सेंड यू द टॉपिक्स आर रिमेनिंग.
ओके.
And stability and instability. So the topics are
ओके, एक सेकेंड. हर्ष चेक करो. सो what are you talking about? Are you talking about precipitation, ice accretion, or are you talking about air masses and clear air turbulence?
Yes, I was actually thinking about the air masses fronts, western disturbance, precipitation, thunderstorms, and the climatology of India. Are they like important to us for this particular exam or?
See, these are important. Okay, all are important, and we'll talk about all of them. तो आप लोग क्या करेंगे? एक बार ये लोग कहाँ पे हैं? Prasad and Aditya. So what we'll be doing is I'll be walking you through the lecture with respect to whatever good pace and quality we can maintain. At the same time, you go through your reading tasks, solve whatever questions you could as self-assessment, and discuss doubts. Okay, it is doable because your basics are strong. So yeah, I'll confirm the timings with y'all. Mostly we'll be aiming for 11 or 1. So I want a poll. किसी को कोई issue है? I want your complete attention and take the best. 10-day hard work and you're good to clear the exam and move on to the next. समझ रहे हैं? और नुकुल, आप भी फिनिश करो इसके साथ as per availability and the pace.
yes sir.
चलो, ठीक है. So 21 and 22 are done. Okay. चलो, I'll ask all a few questions and देखते हैं basics कैसा है आपका with respect to first 5-6 lectures. I'll tell you topics of interest. आपको चाहिए तो 5 minutes quick revision कर सकते हैं. ठीक है? नुकुल, आप भी involved हो. Everybody should be able to answer. Okay? So first question. And try to give out quick answers. You can give verbal answers or you can give it text answers. The best thing that we have been able to achieve to do is to decode meta, speci, TAF. I want you all to really strengthen these. Generally, it could look like something that we would want to avoid because it looks complex and we cannot relate it with a real life experience because we have not yet seen it. But we will be seeing it and this will become our language of communication in certain regards. Okay? Just like RT is. In future, when you'll be getting into more certifications with respect to your planes and more advanced communication systems, you will be dealing with CPDLC also, controller pilot data link communications. Now that language is a very interesting language. And a good thing is you'll already have a resource. That is our RT manual, doc 9432. Correct me if I'm wrong, students. Okay, manual of RT. So there you can just go through that and understand that, okay, this is the digital code for PAN, this is the digital code for Mayday. And voice communication is not the only form of communication. We can do data link communication, that is text coding based communication. And we can still communicate and take clearances and everything. Okay. Essay, good to know information. It is in sync with the language used in TAF, SPECI, METAR. Okay. So anytime you can look for any ongoing real life METAR that is published on meteorological websites and try to decode it. Hush, I would want you to share your experiences if you have any experience with these METAR trends, SPECI, TAF, and how you were recording visibility, fog, what were the anything that you can share. Quick. Take your time.
Sir. So weather is a very important phenomena to understand whether we are on ground, whether we are on sky, because it changes very, very quickly. And because we are working in a very time crucial industry, we have to be very updated with all of these reports. Even if the METAR is not updated, the pilot is like, no, I can't fly. You have to bring me the METAR as fast as possible. So, like even in rainfall, like the whole apron is engaged. No aircraft is like allowed to fly if the visibility is not more than 75 meters. They can't just take off. So they are like just battling with the ATC कि मुझे चाहिए प्रायोरिटी जाने के लिए जैसे ही एक स्लॉट खोलता है फॉग में या रेनफॉल्स में विजिबिलिटी के लिए दे आर लाइक प्रायोरिटी वाइज बहुत फास्ट करने की कोशिश करते हैं चीजों को एंड लाइक बहुत रैपिडली वेदर चेंजेस के कारण भी होता है कि शेड्यूल्स बहुत डिस्टर्ब हो जाते हैं तो बहुत अपडेटेड और एकदम टोस्ट पे रेडी होना होता है ऐसे सिचुएशंस के लिए तो इट्स वेरी वेरी इंपॉर्टेंट टू अस even when I was in Delhi, sir, for deputation for like 4 months, specifically winters में जनवरी से फरवरी में सुबेरे तो लाइक ऐसा होता था सर कि 20 मीटर की भी विजिबिलिटी नहीं है स्टिल द एयरक्राफ्ट आर लैंडिंग दे आर गेटिंग पार्क बट किसी को क्लियरेंस मिलता ही नहीं था टेक ऑफ के लिए काफी लंबे समय तक एंड एक मोमेंट आएगा 5 से 10 मिनट का उस स्पेस ब्रैकेट में सारे के सारे कोशिश करेंगे सिमिलरली सर ऐसे ही मैंने लाइक Patna Nagar was a place in Uttarakhand where I was posted for like an year. वहां भी वेदर बहुत चेंज होता था रिसेंटली बहुत पहाड़ी एरिया होने के कारण तो बहुत सीबी क्लाउड्स फ्रीक्वेंटली बहुत बहुत जल्दी लो लेवल क्लाउड्स जो थे वो देखने को मिलते थे वहां बहुत ज्यादा लाइक क्या बोलते हैं लैंडिंग परमिशन वहां कैंसिल हो जाती थी बहुत ज्यादा वो होते थे यस सर तो वेदर बहुत इंपॉर्टेंट फैक्टर हो जाता है सर समझने के लिए ऐसे सिचुएशंस में
Very well said, Harsh. Classic observation. Like you have lived it, worked it, so we all become a part of it. It's inevitable. Okay. Krishma, are you following? So what have we written
Affirm,
in
sir.
these points? Very nice. These points that we have written here, these are the points that we need to look for because these are the elements that frequently can keep changing with respect to different weather phenomena. Okay. So these codes you have to master and you'll see that you have mastered majority of the report. Couple of things that are not related to this are related to the time, date, and the identifier of the type of report and the identifier of the aerodrome or wherever it's applicable. So these are just different codes. We just decode, remember the codes, encode it any sequence. That's the most best sequence that we have got that we study. In the end, we get cloud coverage and everything. And practice it every day. Okay? Every day make it a habit thinking you're going to fly and you're checking all these reports. That's it. I know. Make it a religion till the time we give the exam. So see, we know location indicators, time applicable. We know the frequent months. Anybody who's regular flying Delhi in this month would know to keep a lookout on the weather and be aware and be able to expedite when weather is good and everybody has to be fit in a slot of just 10 minutes. One good thing about the airport like Delhi, we have almost parallel runways. But yeah, fog, rainfall, visibility disturbs the schedule. Safety is a factor. That's why we take delay. We should never forget it. This type of weather phenomena, which is below any expected minima, is something you should be careful about when you're learning in every segment. If you're studying about winds, then what kind of winds are seasonal? What kind of winds cannot be predicted? Or mostly we can we have at least studied them and we know their pattern. So what is safe, what is not safe, and which part of the country or which part of the world? This is how you apply. And when we are studying something, just make these sections and see. how the memory retention capacity with respect to these is quick and it's very enriching. All right. So I want to understand. Okay. I need 3 important points on fog. Question number 1 is, no, fog is tricky. It's like a moving cloud. You cannot call it cloud. If we recall the session, we have seen some pictures. We have seen some areas in the world where it just travels. Now, I would suggest you don't keep it open book. Okay, Prakhar, go ahead.
So fog is an obscuration mainly due to water droplets, and in fog the visibility falls below 1,000 meter, and it can be classified as thick, moderate, or light. We can
Obscuration
also
due weather or due water droplets. This word obscuration, it's a word that probably we are learning for the first time. We need to be aware what's the difference between visibility and how something like obscuration can affect visibility. So we need to visualize. So obviously, obscuration could mean something related to something being foggy or something blocking my view. So it's always good to look up and check the actual meaning to understand it in depth. We have studied it, but a good point. I'm very happy you started with it. Can anyone give me a read back on point number 2 and 3 as given by Prakhar? I'm having a little problem recalling. Let's see if you remember. Aditya, welcome to the class. बहुत late आए हो आप? Okay, we have an answer. Fog can be dispersed by increasing air temperature or by fog seeding. I would like to know more about fog seeding. What are these terms? Now, Prakhar, you told about visibility falls below a certain number. We try to be very specific and repetitive in our numbers when we are communicating. Okay, to just put an emphasis on where actually is the impact of this weather phenomena, which is fog. Nukul, are you following? The impact is on visibility. The visibility, RVR, very important for us, right? Fog is an enemy of a clear visibility situation. Simple. We won't say enemy, but yeah, it's an obscuration. Now we have a meaning. Obscuration is an act of hiding or concealing something. That's it. Something's there, we cannot see it. So in a plane, that can be very risky. There could be collisions, incursions. Aditya, Harsh, Prakhar. Okay. Answers, I'm waiting. And I'm looking for a poll on the sessions. 11 o'clock, 1 o'clock, any preference? Please. बता दो एक बार. I don't want anyone to miss the session. समझ रहे हैं? लाइव मत मिस करना. आप लोग कीप अप नहीं कर पाओगे शायद. एक दो मिस कर सकता है. But just because of time, you should not miss it. So one more point we got is due water droplets. What do we know about water droplets? We have to cover precipitation. Very important thing would be stability and instability also. So make sure if you have any doubts, you discuss those rates of the stable nature of the environment as a whole is stability, instability. These are important topics, and these topics themselves could get you up to 60%, if not more. Okay. If not more on a bad day. Otherwise, they're good for 70%. I'm just saying you should master them. If you don't master them, then you lose those essential points. Okay, no more points. Prakhar, please give me missing points. Nobody's giving me more answers. What is the value for visibility?
It can be less than 1000 meters.
1000 meters.
Affirm.
Can we fly VFR in 1000 meters? Are we are students?
Negative.
Negative, sir.
ठीक है. Aditya, are you following? Aditya, please give me an update on how many sessions of MET you have done. If not, if it's the first session, let me know. Prakhar, I've got your update. Harsh, I've got your update. Karshma, okay.
Sir,
Mm-hmm.
sir, relative humidity is near about 100%.
Fog. Correct.
Yes.
Now, what do we know about relative humidity? A very important factor. I was coming to this question. I want 3 points on humidity. Quick, students. I want everyone to give me an answer. Nakul, I'm expecting an answer from you. Karishma, you have an exam. Harsh, you have an exam. Please give me an answer. Prakhar, you also give me an answer. Okay. Humidity. Humidity, saturation, water vapor, mass of air, everything is interconnected. Longer length of the runway, shorter length of the runway, humid weather, dry weather, this weather, that weather, those are practical considerations. Apart from any impact that it could have on visibility. The impact on visibility can be done because of fog, because we can see as one point given, relative humidity can be 100%. Students, I want you all to cross-check. Can anyone send me a reference to this? Send me a picture of your notes or screenshot. Okay. Clouds. If we go back to what Harsh was telling with respect to how things are on any airfield, we talk about low-level clouds, CV cells. One of the most bad thing that can happen, the worst thing that can happen is a downdraft or an updraft, bringing with it microburst, cloud burst. Prakhar, do you recall the session from TechGen? Harsh, do you recall the session? Yes, this will work, students. Yes. No. Nakul, are you aware what I'm talking about? Rashma, please talk, yeah. Prakhar, what do you mean? Last date, have you not applied? If not applied, then let me know. Message me. Okay. Are you ready with your answers? Humidity? And I'm looking for a reference to this. Relative humidity 100% in fog. Somebody said you have to apply. Okay, so this session you cannot apply. Next session probably you'll be applying. Because 10th was the last date he's saying, Prakhar. We can always check if they extended the dates. Be on the lookout. But only if you are done till L22, L20 or something, okay? Only then it makes sense. Otherwise, it'll be difficult, but I don't mind if you try because you'll have 24 hours, like 18 hours to study. Okay. I'm not getting answers. What's happening? Okay, I have one update. Humidity, we have saturation mixing ratio. It is the maximum amount of water vapor a unit mass of dry air can hold at any specified temperature. What about this R&D? Relative humidity 100%. Reference, textbook. Nakul, come on. Okay, we have 1 point about humidity. Saturation mixing ratio. Try to give me answers in your own words. Let's try to avoid sharing copy paste, but you can share the screenshot and explain in your own words, like, sir, sharing the screenshot and explaining in my own words. Saturation mixing ratio is a good term. What is it? It's the maximum amount of water vapor. So ratio will be like what? Division. So max water vapor per unit mass of dry air. You need to master the definition of dry air. These are little elements where I've seen students struggle with marking the correct answer, I would say. Maybe they just get confused somewhere thinking, okay, this is not the answer. Maybe this will be the answer. So maximum water vapor unit mass of air. What is the unit? What are the units in which we're measuring the air? Very specific density, specific gravity. Do we have any connection? So we have another input. When air holds the maximum water vapor, it's called saturated air. What is the other type of air? We have to describe. Air can be saturated, unsaturated. What are the advantages, disadvantages? Prakhar, good job. Yeah. Prakhar, why don't you just, yeah, I'll read out Prakhar answers. Humidity is the amount of water molecules in air. Is that the correct definition? Relative humidity is the amount of water molecules in air to the amount of max water molecule air can hold. So now we have second important term, we can say it's relative humidity, individualized. What is relative humidity here? It is the amount of water molecules in air to the maximum amount it can hold. So max actual. If I say, if my relative humidity is 100%, it means if max value is, let's say, 29, then this will also be 29. Actual water vapor, max water vapor. So there'll be this base. Do we know this base? Do we have a physical number to it? Does it change? How do we calculate or how do we come to 100%? Do we understand the fraction, the equation? Come on, I'm looking for answers. And share a screenshot, students. That also works. Not getting answers. Very bad. Relative humidity increases, density decreases. This is the most important takeaway from humidity in relation to density. Prakhar, good job. Please share your thoughts. How can you explain the relationship between humidity increasing with decrease in density?
So density is the amount of air molecules in a unit volume. And if there are water molecules also in that unit volume, then the amount of air molecules will decrease. Hence, density will also decrease.
Think about it like this. You have a device, a computer, or maybe a phone, which has memory, maybe 128 gigabytes, 256, 512 terabytes. You have a limit. Let's say you have 128 gigabytes. Let's say your data has reached 128 gigabytes. What do? You cannot put in more data. When it comes to technology and saturation of data usage, it is never 100%. You get saturated before 100%. Air has limited amount of capacity to hold the entire atmosphere. Air in itself is a mixture of gases. So we can say that whatever the air is composed of, a lot of it connected together all across the globe is making up the atmosphere. Now, atmosphere is nothing but this mixture of gas, and it behaves in certain way. And we have studied one of the behaviors is this, that it can only hold either the mixture of gases, which is nitrogen, oxygen, CO2, and so many other gases, and it can also hold water vapor. Now, water vapor and these gases, they don't go together well. The air that we use in a gas turbine engine or a piston engine, compared to the air that we will use with water vapor, it's not going to give me optimum performance because water vapor exists and it just doesn't exist. It takes the place of whatever potential space we could have had for air molecules. So if I had 100% air and I got 10% water vapor, then I could have still had 110% of quantity. But it doesn't work like that. If I have 100% air and water vapor rises, my air reduces and water vapor will reach to a certain point where it is at its maximum. So atmosphere is affected by water vapor in terms of reducing the available air, and that air is dry air. But we need this water vapor because of the water cycle. It has to rise up. Once water vapor is gone, air is back in that amount of space. So sometimes in the same place, you'll have unsaturated air, sometimes you'll have saturated air. When your relative humidity is 95%, 905%, you're very close to saturation. But atmosphere still has certain capacity to hold water vapor. So you'll need a longer runway because your air molecules are less. Now, is this logic correct? This is the application because we don't need water vapor for combustion and expansion in a gas turbine engine. We need mixture of gases because these are great gases. Nitrogen, 70 what? About 70% nitrogen we are using. Air is our fuel that is burning with a fuel that can be ignited. So we are enhancing the energy of these gases with ignition and controlled combustion, just like we do with nuclear energy. So water vapor is against it. It's basically water, and water is not going to combust like this. Although we have hydrogen engines, but water is not hydrogen, right? It's a combination. So we can say if density decreases, humidity increases. Now it's not a compulsion. Density can decrease with respect to humidity not being affected also. So the real statement that we get is, okay, if your humidity increases, then definitely your density has decreased. So this is the main source of understanding. Because of humidity, humidity is presence of water vapor. I measure it in a unit of relative humidity is what I can say. So I know air has how much capacity to give me pure air or not. Now we don't use the word pure air, we say dry air. So all the definitions of different airs that we have are very important. Who can give me 3 types of air?
So dry air, moist air, saturated air.
Very good. Dry air,
Saturated air, moist air.
moist air, and saturated air. Very good. Do we have more? नकुल, I'm still waiting on reference. आप दे सकते हैं कोई भी reference नहीं भेजा अभी तक. For humidity mixing ratio, we have an instrument called hygrograph, and the unit is grams per kg. Hygrograph. Very good. So for humidity, basically. Okay. So Harsh has given us a equation with respect to saturated air. Harsh, can you explain this?
Yes, sir. So here the 4% water vapor is the max that the air can hold. If the air is holding this much amount of water vapor, it's saturated. It's the maximum that the air can hold.
Who can second Harsh's answer? नकुल, आदित्य, करिश्मा. चलो आदित्य तो शुरू कर रहा है. प्रखर.
Yes, sir, the maximum amount of water vapor which air can hold is 4%, and if it is reached, then the air is said to be saturated.
So what if I have 3% water vapor? So what is my relative humidity? Can it be found? Yeah. What do you think? Aviators, what do you think? Nitrogen 78%, thank you. Oxygen 21% and 1% other gases. Good job. Humidity can be said as a measure of water vapor in air. Good job. सही कह रहे हैं सब लोग. ठीक है. Fog, yeah. Very good. Let me share this. Okay. So I've got a reference and a very important page. We're covering a lot of important points. I hope everyone can see this. Fog is a suspension. We have discussed this. Suspension, this is another term we could use. We have not discussed this actually. Is the suspension of water droplets or ice crystals in the atmosphere or ice crystals. I don't know. I think I'm hungry. मेरे मुंह से ice crystals निकल गया. Anyone hungry here, students? No? अभी आप हंस नहीं रहे हो मतलब आप लोग ध्यान नहीं दे रहे हो ठीक है नकुल आपको तो देख पा रहा होगा if you're not laughing then I know you're not listening ठीक है ना आफ्टरनून सेशन I know आदित्य क्या पहला क्लास तो कुछ भी करोगे क्या किधर है कैन आई सी यू कहाँ है आप in fog visibility reduces to less than 1000 meters and relative humidity is nearly 100%. So we can say that water vapor is the cause for fog. Definition says it and it's interconnected with relative humidity. So humidity, fog, visibility, they all are interconnected with each other. So fog is classified as thick, moderate, light. Important points. Fog is a cloud sitting on ground. We did use the reference of cloud. It sticks to our mind. Fog occurs due to condensation of water vapor. Precipitation is on its way in the layers of air close to the ground. Close to the ground, ground movements can also be restricted. Definitely. Karishma, read the last point. Good reference, Nakul. Keep it up.
The condensation can occur either by cooling of the air to dew point or by creating moisture into the air to saturate it.
This again brings us to a very important point. Cooling of the air to dew point. One of the elements given in all our reports. So who can tell me about your point now? Aditya, nice to see you, looking nice. ऐसा रखो हाथ. हाँ. In education, this is considered to be blocking energies, learning energy. इसलिए एग्जाम में पार्ट टू वाइवा में आप लोगों को ऐसे ऐसे लगा इसलिए यार थोड़ा भी वो फिर ब्लॉक व्लॉक होगा ना तो इंस्टिंक्ट नहीं समझ पाएंगे and थोड़ी मिस्टेक ज्यादा हो सकती है लाइक दीज थिंग्स वर्क बिकॉज दीज आर एंशियंट इंडियन टीचिंग मेथड्स ऐसा जब वो पढ़ते थे ना गुरुकुल एंड ऑल
The dew point is where air achieves maximum saturation.
Dew point is when air achieves maximum saturation. I need a couple more points. Excuse me, students. Okay. Dew point, the definition, what you're saying, Rashma, can you elaborate on it? It seems like it's the same, similar definition.
So dew point is the lowest temperature at which air must be cooled at constant pressure to saturate it.
I missed the first point. Say again.
Dew point is the lowest temperature at which air must be cooled to get at constant pressure to get it saturated.
Lowest temperature at constant pressure. Did you say constant pressure? Now, who can tell me, relate and read the definition? Wait. Let me share the screen, the whiteboard actually. Yeah. So here, I is here, lowest temperature, constant pressure to saturate air. Now, why is dew point important? Now, the question is, why is dew point important? And why is it part of almost all of my reports, especially DATLS and ATLS? Raise your hands. Let's see. Quick, okay, students. I want everybody to try. Now, I have two interesting points of question. Very nice. dP is high if water vapor is high. Okay. And only affected by change in water content. Why? Because it occurs at constant pressure. Pressure is related to density, and that density is basically of the dry air if you have to consider it. The temperature would be related to water vapor. Okay. Hush.
Because if I cool below the dew point, it will cause condensation, and because of which clouds and fog will be formed.
Visibility is going to be affected because of relative humidity being 100% because air is going to be saturated. So at any given point in time where there is a particular pressure reading, if the air temperature drops below the dew point, then you can expect visibility to fall. So if you are given a dew point, okay, if you're given a dew point, and if you check the actual outside air temperature, you compare the two and see where you stand. If you're close to the dew point, then you can expect the visibility to go bad in real time, even while during your operations. Does that make sense? Students, yes or no? Prakhar, please say your answer to the same question.
Sir, if temperature falls below dew point, then it will cause condensation and visibility will be affected.
Same points? Okay. Good job, Nakul. Okay. I want you all to tell me what else. One more question I have. It is with respect to give me temperature at 25,000 feet where my ISA deviation is plus 12 degrees. Try to not use scientific calci, but you can supplement or CX3, but you can supplement your calculation with CX3. And give me an answer to this. It's good if you share your solution. Okay. Easy? Still not easy. We are talking about lapse rate and couple of questions and numericals should be expected on this. So first we take ISA value. ISA mean sea level is 15 degrees Celsius. Okay. So up you go. For every 1,000 feet, you are reducing minus. So you do this into 25. Okay. You do this into 25 because you're talking to about 25,000 feet. And whatever value you get, okay, whatever value you get, you'll subtract that 15 minus whatever you're going to get, 1.908 into 2 point into 25, like this. Then you'll get certain answer which seems like will be in negative degrees Celsius. See if your answers are correct. See if this mathematical way it is correct instead of doing it mentally.
-30.
ये क्या किया है आपने प्रखर, मुझे समझा नहीं है। +12 आपने बाद में किया है। आपने ये 25 कैसे लिया है? How much is the altitude? How much is the temperature loss per feet? तो टेम्परेचर कितना करोगे आप?
Sir, I've taken 2, assuming 2 degrees.
If you have taken 2 degrees, so 2 into 25 कितना होगा?
50.
50. So you're doing 15 minus 50. So you're getting what? -35.
Oh.
So if 15 minus bracket 25, I didn't understand. Is it 25 into 2?
Affirm,
Okay.
sir. It's 2 into 25.
2. Okay, it's 2. Okay. So what is this 35 degrees Celsius, students? This is not as accurate as 1 decimal 908 will give you. The reason we are taking it separately is because there is also something called jet standard atmosphere, which has this value. Sometimes if they're asking about ISA based questions, they might be looking for a specific answer. Try to solve both ways and see the difference between the two answers. So yeah. Now, if this is my ISA value, what is my actual? ISA deviation is +12. So this is what I'm doing. Is it correct? -23 degrees Celsius. Students, tell me if Pragya's answer is correct. Seems simple. Now, you tell me the answer. Temperature at 36,000 feet. I want all answers in the chat box. करिश्मा -35 क्या है? ISA टेम्परेचर है at 25,000 feet और actual टेम्परेचर है. ISA deviation being +12 degrees. Done with answers. Prakhar, very quick. Correct answer is -56.5 degrees Celsius. Okay. One more question. Give me temperature at 44,000 feet. Answers. Mark. Prakhar, Harsh, Prakhar twice, and Harsh twice. Okay. Okay, good. Nukul, नहीं solve कर पा रहे हैं. Karishma, your answer. Aditya, try to follow the math. Are you understanding or not? Please discuss your doubt. कुछ तो पूछ सकते हैं आप. क्या चल रहा है? Good job. Nukul, there is one theoretical rule that above 36,000 feet or 36,300, 600 something feet, temperature is constant for a certain altitude. Okay. Are we following? Nakul, are you there? Victor Tango November Kilo Charlie. Yeah. Victor Tango November Kilo Charlie. Mumbai ground. Up to 65,000 feet. Is it correct? Up to 65,000 feet. Can I get a reference, students? This information section should be clicked as if it's a picture memory for you all to recall these points. Okay? Okay, students? Good job, Krishna. Okay. I want you all to discuss your doubts so far. If there are doubts that we have not discussed till L22 with all these topics that we have covered, please discuss these doubts with me. Or you can keep it shared and we'll solve. It's 36,090 feet, okay? 360,980. 360,980. Zero feet and up till 65,000 feet. Temperature constant at this value. Okay. Okay. We have a question. Let's see if we can solve. Harsh, eyes on the screen. So it is from the test, one of the tests. Students, also do update me on how many tests you have given, like tests on which topic. Okay. मुझे बताना last test कौन सा topic पे था तुम्हारा. Okay. So you're flying from A to B, where at A you have a Q and H 1012 HPA, and B Q and H 1016 HPA. Flying from A to B, okay? The reading on instrument with respect to true altitude is constant. Why? Now remember, true altitude is related to the actual sea level. QNH could very well be the sea level pressure setting for the actual sea level pressure. Can anyone verify this statement? QNH, is it the pressure value of actual mean sea level? All stations, Mumbai ground. How do you read?
Radio 5, Victor Tango, November, Kilo Charlie.
Yeah. The question is QNH. Is QNH a sea level pressure, actual sea level pressure, standard sea level pressure? Actual, right? So they're saying A to B you are traveling. Okay. Where will pressure be more? Pressure will be more at a lower altitude compared to higher altitude. Let's just make field A Okay. And then let's make field B. Okay. Try to draft your HPAs. Okay. Let's see if you can draw the HPA of A and B. Hello, Fadafat. So we can make a mean sea level line. Okay. Mean sea level line, ISA level line. Just for reference, what are we referring with? The first problem that happens in sketching these is sometimes what could be the reference? So I'll take MSL 1013.25 HPA. Okay, MSL. Now with respect to this, I'm going to tell you what is the pressure. So QNH A is 1012. So let's say this green line is my actual sea level pressure. Like this is where my sea surface is. Okay. So here I'll measure the pressure, which will be 1012. Now 1012 ideally has to be above this value because higher pressure will be close to the surface of the earth. So we take the surface of water and we say it is here, this blue line. And we say this QNH here is 1012 HPA. And it is in sync with this. My mean sea level value would have been this. So if I go below, I see that these lines will have higher pressure, higher pressure, higher pressure. 1014, 1015, 1016. So here I can talk about HPA, which is my pressure lapse rate. Who can tell me the value of my pressure lapse rate? It varies with a segment of altitude increase.
At mean
And
sea level, it is 27 HPA per feet.
27 HPA per feet. Some people round it off to some people 30 HPA for quick references per feet. So for are you sure it's per feet?
Up to
Per,
20,000 feet.
is it correct per feet? If I say per feet 20 HPA, then for 100, I'll have how much? So 700 HPA change. Is it correct? This numerical value, Prakhar? Harsh, Karishma?
Sir, it's 1 hectopascal per 30 feet. 1 hectopascal will drop every 30 feet till 20,000 feet.
30 feet,
Okay.
actually 27 feet till 20,000 feet.
20,000 feet.
1 HPA for 30 feet. So we have resolved one obvious confusion that could happen. If so, this is with increase in altitude, every 30 feet, you have 1 HPA. So if you're increasing altitude by 300 feet, you have 10 HPA change. 3,000 feet, you'll have 100 HPA change. It goes on up to 20,000 feet. After that, it's 50 HPA, right? Who can tell me from 20,000 feet to onwards?
40,000 feet. 1 HPA. At every 50 feet, 1 HPA change.
50 feet. So it would mean for every feet we have 1 HPA. So for 500 feet we have 10 HPA, and for 5,000 feet we have 100 HPA change. This change is reduction, not addition. Pressure only falls with altitude. How about above? What is the next range?
1 hectopascal drop every 100 feet at above 40,000 feet.
So this is up to 40,000 feet. Is it correct?
Affirm, sir.
Above 40,000 feet. How much is it?
It's 1
100.
hectopascal every 100 feet.
Yes, very good. Okay. So students, this is what we understand with respect to the pressure lapse rate, and these calculations with respect to understanding what the altimeter is reading, what is the QFE, QNE, QNH, you have overread, underread. Here the question is different slightly. They say that you're flying from this to this, 10 to this, true altitude is constant. Why? One thing I need clarification on true altitude, and why is it constant? Prakhar, we did discuss something similar to this with respect to a doubt that you had. Try to connect the dots and see if you can understand this. So quickly we see here I have 1012 HPA, and I'll mark it in orange. B, field B, I have pressure 1016, this line. So my QNH is measured from here. So sea level is down basically. Sea level can rise, sea level can go down. So QNH 1016 HPA. Now they are saying that your aircraft is flying from here. It has certain true altitude. This true altitude was measured from this particular point. Okay, this surface. So let's say my true altitude was X. This is where my plane is flying. Now the same plane is going here, 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 here. Okay. Now they're saying your true altitude should not have been constant. Why? Because you have this variation of 4 HPA, and because you're at C, 4 HPA will result into 4 into 30 is equal to 4 12, 120 feet. So you'll say that here, whatever your true altitude was, in position B, your true altitude will be X plus 120 feet. This should be idle, but your altimeter is reading same, X, constant, Y. So it should overread. It is not overreading, it is showing the same reading. It means it is showing underreading. And why would underreading happen? Why would it record a lower altitude? The hint is in the option. Okay. And now I'm going to give you the options. Option A, air at A is warmer than B. Air warmer at A. Second option, air warmer at Bravo. C, there is an altimeter error. And D, impossible to say. Now, the correct answer definitely is in these two answers. Prakhar, can you resolve this? So, for A and B to be constant altitude, A would be colder, right?
So because at B the fall of pressure with height is more rapid because at B it's a more colder region. So air is warmer at A and it is colder at B. So isobars are dipping.
Lines of constant pressure are dipping. But ये आपने क्या फर्स्ट पॉइंट बताया फिर से बताना स्टूडेंट्स एवरीवन लिसन प्रखर लिसन एंड टेल मी इफ यू कैन रिलेट
Sir, because fall of pressure with height is more
uh-huh.
rapid in the colder regions than in the warmer regions.
Okay, wait. Fall of pressure with height is more rapid in colder region, okay, than warmer region, okay. How is that related? Next point, batao. Yeah, Harsh, second point. Basically, students, if my air is warm here, then my air molecules are high. If my air is cold here, then my air molecules are low because of contraction. What is that? Density increases in cold temperature. Pressure, यहाँ पे जो pressure होगा वो मेरे को यहाँ पे pressure होगा. Constant pressure, lines of constant pressure. So उसको आइसोबार बोल रहे हैं हर्ष हर्ष ये बताना चाह रहे हैं कि ऐसे में जाऊंगा तो मेरे को कांस्टेंट मिलेगा. So if I have to maintain a constant true altitude to keep safe separation from actual mean sea levels, then this will be giving me this particular safe altitude of true. But they are saying that here when you are, it should overread, but it is still showing constant. It means it is not just constant, it is underreading is also can be said. So how do you explain the last point? Harsh and Prakhar discuss this. Because मैं थोड़ा प्रखर की तरफ inclined हो रहा हूँ कि मेरे को लास्ट पॉइंट नहीं समझ रहा. अगर मैं ये कर रहा हूँ, so how is air warm at air and colder warmer at A? कैसे एक्सप्लेन करेंगे? करिश्मा कुछ फॉलो कर रहे हैं नहीं कर रहे? शेयर योर थॉट्स. Students, I'm waiting. Come on, quick. All stations, all stations. How do you read?
The radio 5
Radio
and
5.
Prakhar, are you sharing your thoughts?
Sir, I'm thinking but unable to.
Harsh,
Sir,
finish
can I
your
say?
answer. Yeah, Nukul, please.
Sir, at A, the air is warmer and at B is colder. So at B, there is a pressure level uh, is low as compared to A. So my aircraft is flying from B to A. So at B, there will be pressure low, and when it is reached to A, the pressure will get high. So as the pressure get high, so my altimeter will be showing underread because we know that as altitude increases, my pressure will be decreases. So here the pressure will be decreases when I reach at A. So sorry, pressure will be increases. So that's why the my altimeter will underread at A.
Okay. So now listen carefully. Now when we look at the diagram, we realize that there is a difference in the QNH in two places. So I'm getting a difference in that amount of HPA and unrelated 120 feet. Okay. So because of that difference, the sea level has gone below. So aircraft's required constant altitude will also comparatively like come down like this. Because this base level 1012, 1016. So if this is 10,000 feet, here I get 10,120 feet. Okay. So I get that added value already. So if there would not have been any temperature difference, then altimeter would have overread. So now they're saying altimeter is not overreading. Why? That's the whole point. Yes, Prakar.
So when we fly from low to high, the altimeter will underread. And here at B it is underreading, which means at B it would be high temperature.
So when you're flying from low to high, now low cold temperature है या hot temperature है?
Cold.
तो हम cold to high तो नहीं जा रहे हैं, cold to warm तो नहीं जा रहे हैं. The correct answer that we have is A is warmer. Why is A warmer? Simple है, students. If my HPA would have been the same, then warm and cold, okay, it would have overread. But my HPA is not the same. So I get this added thing. It is constant because of this difference and this difference between the HPA. There are many ways to come to a conclusion, but we connect it with respect to understanding the HPA level difference and understand what my altimeter should be measuring. My altimeter should be measuring, for example, x plus 120 feet, but it is still measuring x. So the only thing would be that at the same altitude, your pressure is less, and that happens when you're flying from warm to cold. From warm to cold, same altitude, warmer pressure will be less, cold pressure will be more. There's so many linking points. I want you all to go through this point as a reading task and report completion of it. Tomorrow, 1300, we will be beginning. It's a soft update. You all be ready and we'll start with presentation mostly. But yeah, and keep an expected time of 2 to 3 hours in hand. 1 to 5, 4. And schedule reading and solving self-assessment and doubt discussion on a daily basis accordingly. Try not to miss the live session. And if you have any topics of interest, then please one day before you tell me and we'll cover them. And remember, while taking the class, ensuring we are not being distracted, we'll share real life scenarios that we can find and we'll share here on Zoom chat and relate with the same. So let's see if you have more clarity on this. Correct answer as per the master key is air is warmer at A. Air at B is warmer than A, okay? Air at A is warmer. Is only correct. So they're saying you're warm, you're cold. Cold, it should be overreading. Understand the HPA difference also. The key you'll find a lot of altimetry answers here. Difference. Verify if our sketch is correct or if the opposite sketch could be correct. And whatever you find out, please discuss. Okay? Any questions? Okay. So I'll take a leave. Next class, I'm hoping to see everybody on video, so please make such arrangements. Okay? I'll see you tomorrow live. All right, students? Sure. Take care, everyone. See you.
Bye, sir.
Bye, Karishma. Bye, Prakha. Bye, Nukul. Bye,
Thank you,
Aditya.
sir.
Bye, Harsh. See you. Aditya, are you there?
Affirm, sir.
Hmm. So I'll send you an email. आप email से follow the email, okay?
Affirm, sir.
चलो. I'll speak to you later.
Okay, sir. Thank you, sir.